In this video, we will learn about logarithm and its special cases, particularly the common logarithm and the natural logarithm. Logarithm is the inverse of the exponential function. Hence, any exponential expression can be rewritten into a logarithmic expression. For example, we have a to the x is equal to n. In this exponential equation, a is the base and x is the exponent. So according to this statement, we can rewrite this exponential equation into this logarithmic equation. Now this equation is read as log to the base a of n is equal to x. So the base in the exponential equation is still the base in the logarithmic equation. And here becomes the argument of the logarithm. Now take note that n is equal to a to the x. So you get n when you raise the base a to the exponent x. And yes, this logarithmic expression is equal to x. What is x again? That is the exponent. So instead of reading this as log to the base a of n is equal to x, we can interpret this equation another way. That is, we can ask to what exponent x, so that is what we are looking for, do you raise the base a to get the argument n? Again, to what exponent x, we're looking for x, do you raise the base a to get the argument n? Now that interpretation, of course, comes from the exponential equation. So, to what exponent x do you raise the base a to get n? Therefore, we can say that evaluating a logarithm is equivalent to solving for the exponent. Again, if we are evaluating a logarithm, we are simply looking for the exponents. Let's evaluate some logarithmic expressions. First, we have log to the base 2 of 32. So this is equivalent to saying that to what exponent do you raise the base 2 to get 32? Therefore, we have to express 32 as 2, the base 2, raised to some exponent. So we know that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Therefore, 32 is equal to 2 to the exponent 5. So to what exponent do we raise 2? To get 2 to the 5, we have the exponent 5. Therefore, the answer is 5. Next, how about the log to the base 3 of 27? So, we have to ask, to what exponent do you raise the base 3 to get 27? Therefore, we have to rewrite 27 as the base 3 raised to some exponent. Okay, 3 times 3 is 9, times another 3, you get 27. Therefore, 27 is equal to 3 cubed. So now, to what exponent do you raise 3 to get 3 cubed? Of course, you have the exponent 3. Next, we have log to the base 4 of 16. So to what exponent do we raise the base 4 to get 16? Therefore, we have to rewrite 16 as the base 4 raised to some exponent. Okay, we know that 4 times 4 is already 16. Therefore, 16 is equal to 4 squared. So now, to what exponent do we raise 4 to get 4 squared? We have the exponent 2. Next, we have log to the base 5 of 125. So to what exponent do we raise 5 to get 125? Therefore, we have to express 125 as the base 5 raised to some exponents. So let's see, we have 5 times 5, that's 25, times another 5, we get 125. Therefore, 125 is equal to 5 cubed. So, to what exponent do you raise the base 5 to get 5 cubed? The answer is the exponent 3. Let's consider some special cases of logarithm. First, we have log to the base a of 1 is equal to 0. Now, this equation comes from this exponential equation, which is a to the 0 is equal to 1. Now, notice that this is one of the laws of exponents, which says that any non-zero number or expression, which is a, raised to the exponent 0 is equal to 1. If we interpret this expression, to what exponent do you raise the base a to get 1? That again is equal to 0. Second case, we have log to the base a of a is equal to 1. Okay, so we can rewrite the left side of the equation into this one. So we have log to the base a. Of course, to the base a of a. Of course, when we say a, that is actually a raised to the exponent 1. So you have here the exponent 1. So how do we interpret this equation, this expression again? To what exponent do you raise the base a to get a to the 1? Of course, you have 1. Now let's consider a special type of logarithm. The common logarithm is the logarithm to the base 10. But the base 10 is usually not written, such that log to the base 10 of x is equal to log of x. So if the base is not written, that is actually 10, and you have a common logarithm. Let's evaluate some common logarithms. What is log of 1000? So this is the common logarithm of 1000, or log to the base 10 of 1000. In other words, we have the question, to what exponent do we raise the base 10 to get 1000? Okay, of course we know that 1000 is equal to 10 to the 3 because we have here 3 zeros or 3 tens. Okay, so to what exponent do you raise 10 to get 10 to the 3? That is the exponent 3. How about log of 100,000? This is of course the common logarithm of 100,000, or log to the base 10 of 100,000. In 100,000, we have 5 tens indicated by the 5 zeros. Therefore, 100,000 can be written as 10 to the 5. So how do we interpret this expression? To what exponent do you raise the base 10 to get 10 to the 5? That, of course, is the exponent 5. We have another type of logarithm. The natural logarithm is the logarithm to the base e, which is the Euler's number. The Euler's number e is an irrational constant with a value of 2.71828 and so on. Now, in natural logarithm, the log to the base e is abbreviated as ln, such that log to the base e of x is equal to ln of x. So if you are given ln, that simply means log to the base e. Let's evaluate some natural logarithms. First, we have ln of 1. Now, we can rewrite this expression into log to the base e of 1, because again, ln means log to the base e. So, to what exponent do we raise e to get 1? That, of course, is 0. And that comes from one of the laws of exponents, which says that any non-zero number or expression raised to the exponent 0 is equal to 1. How about the value of ln of e? Now, ln again is simply log to the base e. Okay, so log to the base e of e is to what exponent do you raise the base e to get e? And that is equal to 1 because this e here is e to the exponent 1. Lastly, we have ln of 2. Now, to get the other values of ln, such as ln of 2, we have to use a calculator. Okay, for example, if you input ln, if you press ln in the calculator, then input 2, you get 0.693. If you have any question, please leave a comment.